Today we're going to be talking about graphing two variable inequalities, just like we did yesterday. However, we're going to add an extra step to it. So again, our goal is that we'll be able to solve inequalities in mathematical and real-world situations. So our steps still staying the same. Get into y equals mx plus b form. So yesterday, all of them were already solved in that form for us already. We're going to have to do work to get them into that form now. Then we're going to graph the boundary line. So remember, we do that by finding m and b. We plot the b. We begin with b, the y-intercept, and then count the slope. We need a total of at least 3 points on your graph. You're going to determine if it needs to be solid or dashed. And then we're going to shade depending on what type of inequality symbol that we have. So we're just going to look at a couple of examples of this. The first one we're going to look at is if we graph negative 2x plus 3y is less than or equal to 12. And since y is not by itself, we can't graph this yet. So we're going to graph this by getting y by itself. So that means that if we start with our inequality here, we're going to have to get the y by itself. So we want to move the x's. That's the first step of getting y by itself, is to move the x's. And since we want it into mx plus b form, we're going to put that x first before we put the constant. And then we're going to divide by 3 to get y by itself, and we're going to do that by dividing each individual piece. So now we have y is less than or equal to 2/3 x, that doesn't simplify, plus 4. Now that y is by itself, we can look at and figure out what our m and b are. So m is 2/3, and b is a positive 4. So when we graph those, we're beginning with b, that's the y-intercept of 4, and then we're going to count rise over run. So we're going to go up to right 3. You're going to do that again, or we can come back the other way and do down 2 and left 3. Now, looking at our symbol, we have y is less than or equal to, so do we need a solid or a dashed line for this? We're going to need a solid line. So we're going to connect those all the way through the graph. And since y is less than or equal to, we're going to shade above or below. That's right, we're going to shade below. Okay, yesterday we talked about testing points, and you can still do that. I'll show you how it works. So if we test 0, 0, should we get this to be a true statement? We should, since it's in the shaded area that we just did, so let's check it out. So we're plugging in 0 for both x and y in the original inequality. So negative 2 times 0 is 0, 3 times 0 is 0, 0 plus 0 is 0. Is 0 less than or equal to 12? It is, so we know that we shaded in the correct area. Okay, so you can always choose a test point if you would like as well. All right, the other one we're going to look at here is 3x minus 5y is less than 20. And again, it's not in y equals mx plus b form, so we're going to get it there first. 2 steps to getting y by itself. We need to move the x's, so since they were positive 3x's, we're going to subtract them. Don't forget this negative. So we have negative 5y is less than negative 3x plus 20, since that's a positive 20. We're going to divide each piece by negative 5. So that's going to give us y. Since we divided by a negative number, we need to flip the sign. Negative 3 divided by negative 5 is a positive 3/5. Keep the x. And 20 divided by negative 5 is a negative 4. So now we can choose m and b and go from there. So m is 3/5, b is a negative 4. We begin with b, so we're starting here at negative 4, and we're going to count up 3 and right 5 spaces and do that again. Or you can go down 3 and left 5 spaces. All right, so now that we're here, we have y is greater than 3/5 x minus 4. So when we go to connect these, are we using a solid or a dashed line? So we're going to be using a dashed line. Again, you're just lifting your pencil every so often. And since it says y is greater than, we are going to be shading above the line. Okay, you could choose to test a point if you want, but just keep in mind you must get y by itself first before you can find m and b. If you divide by a negative, you have to remember to flip the sign, and you can always test a point at the end to see if you were correct or not.